when you were talking about that no start thing back in the day, and part of the 1984, I was working at Lincoln dealership in Dothan, Lincoln Mercury. Now it's Lincoln, and there was a lady that I knew that had a 81 or 82 model town car that she brought over, and she said when they drive it for 5 minutes, first thing in the morning, it would cut up. Then it would straighten up, and the rest of the day it'd be okay. And so when I got through with my diagnosis on that, there were no trouble codes on those, unless you knew how to activate it. Then the trouble codes were so clunky. Basically what you would do is you pull a vacuum on the baro sensor port, like 10 inches of vacuum, and it would force it into a self-test thing, and it would use the thermactor solenoids to go back and forth, and it would flash the codes, and you had to understand the pattern and all that kind of stuff. I built a box to do it with, because as far as I knew, Ford never came up with anything. We didn't have it. Anyway, long and short of it was, when I found her problem, the wire, there was a wire that came from a crank sensor, and it was a blue and gray wire, just like they use now on this Ford stuff, and it was pushed back in the connector right over by the throttle body. You couldn't see it unless you unplugged it and looked in there, and one of them wasn't latched in good, and it just barely was touching. I don't know what the 5-minute deal was, but when I fixed that, they never had that problem again. So a lot of the times you don't ever know what temperature and all that's going to do. Where is Nick? Anybody know where Nick is?
He probably went to go get his jacket out of his vehicle, that's where he normally goes.
All right, well, he must be thinking it's cold in here. All right, so let's talk starters. A DC electric motor with brushes, you understand how a DC electric motor with brushes works? Do you or do you not understand how a DC electric motor with brushes works? If you have power and ground going to these, each one of these commutator segments is hooked to, got its wires wrapped around one of these poles, and then on the other side. All right, and so you got a, notice you got a south and a north here, and a north and a south there, and they're opposite one another. So whenever you put this power and ground in here, you're going to create a magnetic field on the one that's next to this one, and it's not going to like it. How many of you guys have ever took a magnet, called a magnet, you put the two north poles together, they do this, it's the same deal. It rolls away from that because it can, because it's got bearings on each end. But when it rolls away, the brushes are stationary, they stay in the same place, and so the magnetic field is still opposing. All right, and so here we wound up with this thing spinning. So you put power and ground there, you know, depending on how it's wired and how it's wound and how many of these it's got and how they're set up, it'll whirl that motor. You can do work that way. And the difference between an electric motor, even an AC electric motor like a hybrid we've got, and an engine, like an engine like this one here, has got to build up to its maximum torque, you know, when it's a certain RPM. Well, an electric motor, as soon as you hit it, it's wide open solid. I mean, you get full torque from it. That's what the Tesla car, you know, the people that drive those, if they want to do something silly like that, you can burn the wheels off of one of them things. You know, it's strong. But anyway, brushless DC electric motors, you got to put the magnets on the part that spins, and put the magnetic windings on the outside, sort of like an alternator with a permanent magnet rotor. Only you're feeding a stator instead of harvesting its energy. So basically, you're basically got all this electronics here that's going to cause that magnetic field to chase this magnet around. Now that seems like, and you'll be surprised, how many of you ever seen a little computer fan? You know the fan that goes in your computer, the little small one? All right, that is a brushless DC electric motor. On those, you cannot reverse the polarity and have them run backwards, even though they run on 12 volts. Got it? Now the brushless motors run on 12 volts. You can hook it up to the car battery and it'll spin if you got the red and the black wire right. But what you don't know is if you pop the fan off of there, you're going to see all kinds of electronics in there that's wired up to do this. Because what's the problem with brush motors?
Brushes go bad.
The brushes wear out because they're sliding on there all the time. All right, this is what they look like in there. See that little electric circuit board in there? You pop that off, there's a bearing in the middle. This doesn't turn, this does. So basically, the little windings are basically that these electronics are going to kick that magnetism around and around, and there's a magnet around here, and it just whirls around there, see, basically. All right, so hybrids use AC current and high voltage to drive their big motors. Now they got brushless motors, and they basically got 3 windings going to them, and then they got these IGBT transistors you know, that are really strong. You have to take a lot of cooling, and they basically, you know, they walk the, and on a hybrid vehicle, a lot of you don't know is that when it's got these two electric motors in the transaxle, you know, there's a planetary gear set in there. All right, so the planet pinion is connected to the engine, and the sun gear is connected to one of the motors, and the ring gear is connected to the other one. And sometimes during various parts of your gearing, one of the electric motors will have to be running backwards. The engine can't run backwards, but the electric motors can. And you know, but you got to realize that they're not always running the same direction. Anyway, you got to feed pulses to the external fixed winding, so there are times with the north-south swapping of the permanent magnets built into the rotor. You're taking a DC and turning it to AC inside the motor. All right, now starters work really hard. They got a tough job to begin with, low voltage, whether it's from a weak battery or voltage drop due to bad cable connections, will overheat a starter the same as if you were to stall it out trying to spin a half locked up engine. Imagine yourself with a locked up engine and a good strong starter and good strong voltage, and you keep trying to start it, and the starter can't spin. What's it going to do? It's going to burn out. It's going to be destroyed, right? So if you've got low voltage, it's having to work all that much harder with all that many more amps, and it's going to cook that starter. Low voltage will cook a daggone starter. All right.
Thank y'all.
Amen.
Y'all found a new lens for the rear, didn't you?
Yeah, we actually got a lot.
Did you have to change the rocker switch too?
Well, we were going to put a switch on it, but he said after he did put the fuse in there and wired it all back up, that he didn't need a switch.
Excellent. We do thank y'all.
Yep. So we appreciate the sandwiches too. All right. This is what happens whenever starters have worked hard enough to where they start to come apart. See those brushes where they slide on a commutator? That starter came off that white Chevy truck out there, the one that we got back whenever Gene was using it. And it was found that it was horrible. We pulled it apart. I took a picture of that because it's a good illustration of that. What happens when low voltage destroys the starter. All right, so stealth voltage drop. Sometimes you can see the place where a voltage drop is happening, and sometimes you cannot. This one right here, you see how that's cooked and burned? When you see a connection that's cooked and burned, it's getting hot like that, it's going to be dropping some voltage there just because of oxidation and heat and all that. This one right here looks just fine, doesn't it? Not loose, doesn't look like it's been getting hot, but yet when you took this off and pulled it out of the way, look at all that paint. And the only connection you were going to be getting was between this and there and whatever you could get down in that hole. I want this to have a good bite on the block. So it's always a good idea to brush those bosses, make them really shiny, and brush your everything you can do to make a nice even connection. And it wouldn't hurt if you put a little dielectric grease on it and keep it from oxidizing. That girl brought that fusion in here, so her fan wasn't working, and we ordered a connector for it, but I took that little pick and I tightened those terminals up, put some dielectric grease on them and plugged it back up in there, and she said, well, I got that wired terminal thing, but my fan's been working just fine ever since you did what you did. And I said, well, just do what you got to do, you know. Of course, if it gets hot and burns out her, you know, blower resistors, you won't like it either. Hey, come in here, Judy.
Just keep this on your desk. I was going through my stuff and I figured you wanted this back. Do you put anybody anytime today that wants to do another thing on my truck?
Yeah, we'll do it.
Come let me know when.
All right, thank you. Bring it back right after lunch. You want to do it? All right. That's Judy. She made the short list. Okay. All right. The new saline comes in with no starter operation. Trainee checks the power at the starter. And this is what you do, guys. You hear me? Listen to this. You want to see if the starters get any power to this secondary terminal that triggers that solenoid. So he got under there with his test light and he found good strong power right there. And he had good strong power right here. But nothing was happening at the starter. All right, so having no clue what voltage drop was all about, he figured, well, if I got power here and I got power there, must be the starter. This thing wasn't very old. He reminded me of, Nick, did you do this one time? All right, so you replace the starter, still no crank. And this wasn't an easy job. All right, so he found a bad negative battery cable connected to the engine block. Now what you could do on this one, you could hook up to, watch this, you could hook up to ground, right? And you could touch the engine block with the test light. And when you turn the key, the whole block would light up. Because that was the only place, through the test light was the only place it couldn't get any ground. See what I'm saying? All right, so we brushed the anodized bolt and the engine paint away and the problem gone. Have you seen these bolts? It's got this color to them. It's like someone like pink and blue and all. It's anodized. And I don't think that's a problem ordinarily, but this anodized bolt, it was tight. It looked good. It's just like that other thing I showed you. When we put it out there and we brushed it off real good and brushed that terminal and everything's on the side of the engine block, kind of like where I got it right here. And we clicked, and that's all it needed to get that Mustang going. What's so silly about that? That same guy, a year later, got another Mustang with exactly the same problem and went down exactly the same path. He checked it with that test light, put a starter on it, and found out he had bad voltage drop on the engine block. I mean, went through all that work. All right, when somebody comes in with a vehicle, got a new starter, new battery, but the starter's still straining to turn the engine, get the voltmeter, make the necessary connection, find out where the voltage is being lost. Understand voltage drop. That's the most common problem you're going to find. It's called, if you've got a headlight that's dim on one side of the car, go to the light that's hot, go to the battery and see how much voltage you're losing between the positive battery terminal and that headlight. All right, if the engine's mechanically unbound, it's a smart thing to do. All right, so it's wise to check for mechanical binding and pull the belt off, see if it starts up good then. Now let me ask you this, I come in here, I got click, 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 it won't start, you know, sound like a bad starter or something. Take the belt off and it starts up, what does that mean? Take the belt off and it fires right up.
You got something that's seized or that's locked up?
Something locked up.
Yeah.
Water pump, AC. It'll be one of the big pulleys. I don't know if I've ever seen a power steering do that, but I've seen AC do it. I've seen, yeah, the water pump do it because they got big pulleys. Now, why do they have a bigger pulleys? Why do they got a little bitty pulley on the alternator and a great big pulley on the AC compressor?
Because they're pumps.
The
Wait, no.
smaller it is, the faster it rotates.
Yeah.
That's smart. That's a smart answer. It's got to spin faster. Well, the bigger it is, and it doesn't. The AC compressor doesn't have to turn all that fast, but it does need a lot of power. So it needs a lot of belt traction on that big pulley. Power steering the same way. It's got the biggest pulley on there, other than the crank. See what I'm saying? And the crank's actually what's making the power. All right. So, little used vehicle is only driven 2 or 3 miles each way every day. May need a starter at low mileage because mile for mile it's been called on to start the engine a lot higher than higher mileage vehicle. My wife, we sold my dad a Tempo that my wife drove for 8 years and put 28,000 miles on it. And within 2 weeks of him starting driving, it needed a starter. And my wife says, why does it only need a starter? All it needs a starter, it's only got 28,000 miles on it. I said, you started it a heck of a lot for those miles. So she just went to the bank and back every day, 3 or 4 miles. So she started it twice a day and didn't put many miles on it. You see what I'm saying? So you use up a starter there. And that's what goes on there. So just because an engine is a low mileage, because a vehicle is low mileage, especially if it's got years on it, doesn't mean that the starter, there's only so many starts left in a starter. When you start it the first time, there's only so many times it's going to start a vehicle, and then sooner or later it's going to stop starting the vehicle. Because starters stop sooner or later. And there's only so many alternates left in an alternator. That's me talking funny, but you know what I'm saying about it.
Yeah.
All right. 2007 Taurus. Starter died suddenly at about 100,000 miles, and I was forced to jack it up in the driveway and replace it with a parts house unit from around the corner. It's my car, the car I used to drive. Matter of fact, it sounded funny down at Winn-Dixie, and then when I got back up to the house, I went and started, So I go to that starter. Started flawlessly for about 2 months. And then one day, when I got behind the wheel, right out here to go home, the starter motor would start to spin as soon as I turned the key, so that it was whirling full speed before it hit the flywheel. I mean, it was banging the flywheel really hard. And this would seem like a theoretical impossibility. Well, why? Because when you have this battery terminal here, you energize that solenoid winding. This is supposed to come back, and when it's come back, it's supposed to, let me go ahead and do that. It's supposed to pull that lever first and engage that gear in the flywheel. Before it ever touches these connections right here, this is already supposed to be in the flywheel. You got that? All right, so what we wound up doing, I mean, something in here, I could not visualize, and you couldn't take that solenoid apart without cutting it. I could not visualize why that thing would start whirling the starter the instant I hit the key, and then this would already be spinning when it was trying to engage the flywheel. That's just don't work. And if you do that too many times, you've knocked a bunch of teeth silly on your flywheel and you got to put flywheel in it. I was smart enough to where the second time I tried that and it didn't do it, I stopped. And I said, this thing's got a problem with starter. I had never seen one do that before or since. Other people may have, I don't know. And that happened about, I don't know, 2 years ago on my car, or maybe a year ago. Because I don't have a car anymore. But anyway, the point is, the brushes are here, commutator's there, armature's here, permanent magnet's here. There's your overrunning clutch. Now, if this stays in, if that overrunning clutch stayed in, then you basically hear all that racket. You know, whenever somebody's still got the starter engaged and they go ding 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 ding, you hear that ringing. No, that's an overrunning clutch. Is what that is. Now, any of you guys ever worked on Briggs & Stratton lawnmowers? You know where you got to pull it and start it. That little thing has got an overrunning clutch in it. And basically, it's got some little balls that fall down in there. You've took that apart and you've seen the little balls that rattle around down in that overrunning clutch. It works a similar way. Don't worry, you will. All right. All right. Now, with the whack-it method. Remember the whack-it method? We went over there, me and you, to the library. You was trying to help that guy get his truck started. Wouldn't start. And I got something. I got this big old hammer. And I went around there and I said, all right, try to start it. And I just barely touched it with it, tapped it, and it, man. Well, see, you basically jarred those brushes and got it started spinning. So if you can tap it, don't beat the crap out of it. If you hit it too hard, and that turns out not to be what the problem is, you done busted those ceramic magnets, and now they needed a starter they didn't need before. So be really careful about that. One day this lady came, somebody said replace her starter on her Chrysler because you had to whack it, and she still had to whack it, but it turned out that this little screw, do you remember when you was taking a starter apart, the little screws that went into the brush holder? Remember that? If that screw's loose, that brush holder depends on the ground right there so that it can actually run the starter. And on Power Stroke diesels, I used to see that. Somebody come in on the hook with a 97 or 98 Power Stroke diesel. They say, my starter don't work. I'd get under that thing in the parking lot, and I would see that scorching around that screw right there, and all I had to do was take that screw out, brush it really good, tighten the other screw up. That truck was fixed and on the road in 10 minutes. I did that a bunch of times on it. I don't know why they were working loose or whatever. This was a rebuilt starter, and that screw was left loose when they rebuilt it. It passed a few bench tests, but she was having to whack it to get a, she said, I still have to whack my rebuilt starter to get it to spin. Anyway, I thought we kind of know that. All right, so what's this right here? This Lexus starter solenoid taken apart shows the copper washer. There's the copper washer, and these contacts are the ones that it smacks against whenever it's pulled forward. Now you might notice your battery terminal connects here on this one. There's your solenoid wire. Over here is the one going down into the starter motor. So when the connection is made between the battery and the starter motor, that's when it whirls. But as this is pulled back, that gear engages the flywheel. Now, on the President's Cadillac, the 71 Eldorado, right after he got it, the starter, it came in here, and he said that it wouldn't start sometimes because it would just swirl the starter. We got under there and looked, and here, there, and yonder on the flywheel, there were teeth knocked off. I mean, like one tooth would be knocked off. Now this starter didn't go on there like a regular GM starter. It bolted in with ears, not bolts going up. Okay, so Bobby Lundy pulled the transaxle out of this doggone thing and got the flywheel replaced on it. We put it all back together, and about the fourth time we started it, that starter knocked a tooth off the new flywheel the same doggone way. Okay, so what did I do about that? Okay, so I said, okay, we're going to get another flywheel. And we got another flywheel. And I said, now, do you notice the little bevels on the starter teeth, on the leading edge of the starter teeth? I figured out which way the starter teeth went in there. And I got my little high-speed cutter, and I went around that flywheel, beveling the teeth on the flywheel the opposite way of the ones on the starter so it would ramp in there. Because my contention was, if that starter hit one of those square-ended teeth hard enough, with that thing as brittle as it was, it just popped that tooth right off there. It wasn't shaving them off. It was hitting it hard enough to just knock a tooth off. And when it did that, you were hearing wing, and the caddy wouldn't start. Well, after I ground the edge off every one of those teeth, and it didn't take 45 seconds to do that, turning and going ying, ying, ying with a high-speed cutter. And then we actually egged the hole on the starter so we could adjust it closer. And he's never had another problem with that vehicle since then. Anyway, that was a little bit of engineering that had to be done on that old 71 Cadillac. All right, So a lot of common platforms for the last few years have been giving the PCM full control of the starter. And I'm not just talking about the push button ones. You guys notice when you crank some of these late GM cars, if you just touch the key and let go of it, it goes ahead and starts up? You notice that? I mean, because all it needs to know is it sees that start position and the PCM says he wants to start, I'm going to operate the relay, we're going to fire it up. It uses another function whenever you're using your remote start, you know, and all that. So, all right, so if this PCM doesn't wake up for one reason or another, we know starter operation. So don't neglect to rig out the scan tool before you condemn the starter. The starter relay on these Impalas is built into the daggum fuse block. You will not change the starter relay on some the late model Impalas because it's part of the box.
You can't even.
And we've had to replace an entire box. How it's up there on the behind your head on that thing, one of them boxes we had to replace because of that. All right, and so your ignition switch. See, look at this. That's 1, 2, 3. There's your start, and that's 1.3 thousand ohms. Body control module is receiving that signal, right? Then you got your network here, and your body control module gets that signal, takes it through the network to the engine control module. The engine control module then, see all of the stuff that's got to happen before it starts up? You better understand this and know how to rewire schematic. If you don't know how to rewire schematic, you don't fix nothing. Got it? Also, you got to recognize that on some of these GM cars, the ignition switch will go bad if it's got that security system. And if you have to, if somebody says, when I try to start the car and it won't start, or maybe it starts and dies, and I got to wait 20 minutes before it'll start, that's going to be that ignition switch coming because of bad security stuff. You know. Anyway, got to simplify the schematic here. You know, there's your BCM. You know, talking about ignition switch talks to the BCM, and your main PCB relay turns on. See all of that, the middlemen that are in that situation, how you got to understand that? There's your starter relay over there. All right, and this is what it looked like on the car when we were troubleshooting one of them. And we were getting back here behind the, you know, the appropriate wire. We had that little pick in there we were checking, and that's how we discovered that fuse panel was going to be replaced. Because none of these relays here is a starter relay. If you see it drawn in the middle of that thing and there's no pin assignments, Toyotas are like this. Fuel pump relay on the Toyotas are in a module like that too, some of them. All right, so that was the crossfire story. That's that stove that covered up. Sometimes the crossfire wouldn't crank. No starter operation. She said, I go out in my garage, all ready to go to work, get in the car, I got nothing. Battery's up, can't jump it off, won't start. So she goes to a Chrysler dealer, I'm not going to say which one it was. $2,500 later, she still had the same problem. They replaced the engine controller and who knows what all else. Just throwing stuff at it. You know what I mean? I mean, I don't know who worked on it, how much experience the mechanic had or whatever, but anyway, she brought it here just because she was just put out there. She was a really nice lady, not to go back and tell them, hey, I want my $2,500 back or I'm going to bang you over the head with a frying pan. You know? All right, so the analysis of the circuits. We got a relay control module. And that relay control module, when you turn it in hot and start or run, it's going to turn. Look at this. A relay control module, I'm sorry, the engine control relay is built into the relay control module, which is not the fuse box, although it has the fuses to it. All right, the PCM turns on. All right, there's your ignition switch output. See all that stuff right there? Starter enabled. All right, and so the pulse module will not let the starter operate if the engine's already running or until you switch the key off and done it again. Now, if you didn't know anything about a Volkswagen, even today, if you try to start it, if it's one with a key, and you let it back to the run position, unless you switched it all the way off, you can't start it again. It won't let you, or it's because they don't want you to tear the starter up. Yeah, I guess German vehicles have been that for a long time. I mean, I saw it on Volkswagens in the early '60s and before, you know.
So you pretty much just can't crank it after you start it and left it in the run position?
Yeah, you got to switch it back off and then do it again. You always have to go to the off position before you can start it on those cars. One time, and this is kind of funny, I don't know what my time looks like here. One time we had one of these cars out here. Have you ever seen one of these cars that has what looks like an ignition key placement, there's no key goes in it, and you got like a fob thing, and you turn it like you would a key to start it, but if you don't have this fob in the car, it won't work. And so And this one here, no, I'm talking about this thing here, it's just got a little thing on the side of the column, and some of these Nissans, Toyotas, I can't remember what it is. We had one out here, they had a bunch of dual enrollment students out here. And I says, okay, get in there and start that car. Well, I had the fob thing in my pocket. And so I had the fob thing in my pocket, and I got in there and I says, can you start for me, please? And I turned the key and it started up, or I turned the thing. And then I got out. And I says, okay, get in there. And so one of these guys got in here and he tried to start it. I said, well, tell it to start. He goes, would you start for me? And it wouldn't start. So I said, you're not even saying it right. So I got in there and I said, would you start for me? And it started up. He goes, this is one of those voice-activated cars I've heard about. I've never heard of a voice-activated car. That tickled the stew out of me. Anyway, I showed him what the deal was. But I mean, that was a strange car because it had a place where you could turn it, you know. I don't think there's very many of those around. I don't think what kind of car it was. It was Toyota Corolla or something. I can't remember. But anyway, somebody on YouTube sent me a message and remind me what kind of car is set up there. Okay, now, here's the pulse module. Pulse module on the left side over there, a little box over here, and it's basically the one that I showed you in that previous schematic. Driver's side of the brake booster. All right, so I got this Hickok flat recorder. This Hickok flat recorder is pretty doggone cool. All right, the Wincon thing. Anyway, so I hooked it up. It'll record 4 channels, battery, injector, pulse, ignition, and 1 auxiliary input. I had my suspicions as to what was going on, so I basically connected it to the ignition, the fuel injectors. The battery, by default, it's connected to it, it powers it up, and I hooked it to the wire going out to, coming out of the, going to the powertrain control module from that relay, right? Okay, so I connected it to that, and then there's a little button that I pulled in there, and I taped it to the gear selector, and I says, now, the next time you get in this car and it don't start, I want you to make a recording. Now, I made a recording where it was starting. We couldn't get it to repeat. So I says, she drove it 2 or 3 days, and she came back, she said, it did it yesterday morning, this morning it started, and I brought it in. Made a recording when it didn't do it. I'll show you what we're looking at on our screen here. Hello. This is what it looked like. There's your battery. There's your spark. There's your pulse width. There's your auxiliary. See that? This is when we turn the key on. We had spark, we had pulse width, all that. It's a very simple recording. You know what I'm saying on that? Now this is what it looked like when it didn't start. We still had good battery. We had no spark. We had no pulse width. We had no starter operation because the PCM never woke up. We didn't get anything here except a little bit of, weak whatever. A little spike right there. I don't know what that meant. But the simple fact was, my suspicions were confirmed. We put this little box on there. That box is over close to you somewhere, laying up over behind your head. I mean, it's on that shelf. But the simple fact is, that's what the box looks like. $450 for that box. And it's actually, if you look at that box, it says Mercedes on it. Because this car is basically a overblown Mercedes. We changed the engine control relay. And I told her, I said, we're going to have one of these. So she said, okay, go ahead and do it. So we plugged it in. I showed her this recording, and she's pretty sharp cookie. She understood what I was doing. And so this solved her problem. But here's the other thing. You've got to understand how this stuff works, or you'll never really figure it. You're not going to do it by cleaning the battery crumble and throwing a starter on it every time. You know what I mean? My pickup truck, right now, it's sitting at home. Surprised me last night. I turned the key. I had good lights on the dash, but I've got nothing. And I was thinking, well, is this maybe passive any theft? I didn't plug a scan tool in. I just went and got another key right quick, and I didn't start it either. So tomorrow, I got to troubleshoot my own doggone 07 F-150. Fortunately, I had another vehicle. Okay. Don't neglect to check the PAT system for codes on the no crank. Some PAT system won't allow starter operation, some will. Passive any theft. Okay, you got that? 1601 code, B1601, where if you see a PATS code and it ain't starting, or if you got one of those I was talking about that you got to wait 20 minutes to start it, and you see a fuel cut, if it's vehicle theft detected and disabled or whatever, make sure you go after that before you start throwing starters at it and everything. Slow or no cranks, don't forget to check starter current draw. Anything more than 225 is generally too much, and that's me talking. That's sort of a rule of thumb. Usually you're going to see just under 200 amps, if everything's like it ought to be. Be sure to check for voltage drop on both power and ground circuit. Make sure your battery's good and strong too. Don't do it on a weak battery. Remember, anything you're losing is voltage drop, it may get the starter. When you see a secondary ground like this one right here that is absolutely fried, it means that's the only ground it has. it's having to go